Welcome to April 2nd, Organic Chemistry. All right, so hopefully you took your quiz yesterday on sapling, and you should have gotten feedback on that quiz once it was submitted the next day. Today we are going to do enamines. Okay, so we're going to talk about enamines and how they act as nucleophiles. And I'll also tell you why enamines are important, okay? So at this point, you're finished with your POGL. Congratulations, finished with POGL. We've talked about the mechanism. So let's just recap the mechanisms of alpha substitution. And you can do this with, we've talked about ketones, aldehydes, and esters. And so that means like if you have a ketone here, then alpha substitution, you would usually use LDA. You make your enolate, and then you'd react it with either you can do just an alkyl halide, which is your electrophile, or you could use another electrophile such as a primary alkyl halide. And so if you use a primary alkyl halide, then you get something that looks like that. Okay, so that was alpha substitution. The other reaction, we've talked about aldol condensation. We've also talked about Claisian. So here's your aldol. Claisian uses an ester. Okay, and then we've also talked about the Michael addition. A Michael addition would look something like this, where you have an alpha beta unsaturated carbonyl. And we talked about how this so here's your 1, 2, 3, 4, and this 4 is a delta positive, and soft nucleophiles will attack the 4 position and add to that carbon. And the fifth reaction we've talked about is we talked about the acetoacetic acid synthesis with decarboxylation. These were all in your POGL 23A through C. The acetoacetic acid. There's your acetoacetic acid. Of course, this is an ester here. And we react this with like sodium ethoxide because there's your ester. And we make the enolate there at that carbon. The pKa here is, I want to say 11. You can check me on that. And then you can react that with an alkyl halide. And you get alkylation there. And then you treat this with H3O plus and heat, and that does a hydrolysis of the ester, and then this also does a decarboxylation. We're going to lose that CO2, and then it's going to make 1, 2, 3, 4, 5 a ketone. Okay, so those are 5 reactions that we've talked about, and now we're going to look at enamines. Now, why are enamines important? What is an enamine? Okay, what is an enamine? Usually you do a secondary amine. Okay, so there's your secondary amine. And if you react this with a ketone, there's your alpha hydrogens. You're going to lose water. So you're going to lose this hydrogen, and this oxygen to form an enamine. Okay, let's try this again. And, all right. Do this again. Enamine. There's your double bond. And this is your amine. Okay, it's a neutral. And we've talked about this in the amine chapter. Now, in amines, you have a nucleophilic carbon. So this alpha carbon is kind of like a mass nucleophile. Okay, now, so you can react it with an electrophile, such as benzyl bromide. Okay, and so what happens is these electrons here on nitrogen push here, and these electrons go here. This is your SN2, and that is how you alkylate the alpha position. And you form a new bond, this carbon here. Okay. So you got the Br minus there to make a salt. And then what you do is you hydrolyze this. So when you add with water and acid, these imine, this is aminium, salt, will hydrolyze. We've done this mechanism back in a few chapters back. Water comes in, attacks that carbon there. And deprotonate. Do you remember all those steps when we did like 6 steps? Deprotonate, reprotonate. We're going to, this gets protonated. The carbonyl reforms here. And then the pyrrolidine leaves. This is pyrrolidine. Okay, so it leaves and you reform your carbonyl there and you've alkylated. Now, why would you want to do this? Because in reality, aldehydes and some ketones are too reactive for alkylation, alpha alkylation. Okay, so one of the ways to do this is to mask with a secondary amine, and then you are able to generate the alpha carbon nucleophile through this protected enamine. And then you just treat it with some acid and water. You can actually do that in your separatory funnel. Okay, so they're a little less reactive than your typical aldehyde or ketone enolate. This reaction, where you use a secondary amine to do alpha alkylation, is called the Stork reaction. And I used to have friends that studied under Gilbert Stork. Gilbert Stork at Columbia University. Okay. Now notice you can also do acylations. So let's do that real quick. Okay, so if you take this ketone and you react it with pyrrolidine, 1, and then you react it with acetone, or no, acetyl chloride, and then the third thing you treat it with acid. All right, so what do you get? Well, step 1, you're going to get the Enamine. Okay, so that's your protected alpha carbon here. So this is your alpha carbon. Okay, this is going to be your carbon nucleophile. And your delta positive here is this carbon. This is an acid chloride. So this is going to be your electrophile. So now these electrons on nitrogen come here. Those electrons push. Those electrons go up, come down. Cl is a leaving group. And now you formed a new bond at your alpha carbon. And you form this iminium ion. And third, you add acid and water. You can do this in your separatory funnel. It will hydrolyze the iminium ion, so you get your ketone back. So you get your nice little ketone back. Now notice, let's look at this product. What is this product? You might want to get this in your reaction sheets. This is a alpha beta. This is a beta keto ketone. So we know that this alpha hydrogen is very acidic. What do you think this pKa is of that hydrogen? I think if you look it up, you'll see it's a pK of 9. Okay. And so then you can alkylate that carbon there, just a little bit of sodium hydroxide and another electrophile. And that is the Stork alkylation. All right, so I will give you a reaction to do, and I will make another video for Monday. But I'm going to give you a few just reviews of the previous stuff. Okay, so these are your online Pogles. So let's do online Poggle, and let's keep them all together. So now that you've done all your Pogles, then let's make this for next week. Okay, so let's include this for next week, include all your next week's online Pogles, and we will say this is due April the 8th. April the 8th is also Quizam 4, so I will post your wrapper today. Okay, and work that front sheet, send it to me. We're trying to get you, your Poggle points. That's worth 5. The goal is 50 Poggle points, so just keep working it. You'll get there. Okay, so I'm going to give you some online Poggle problems. 1. Okay. I want you to fill in this reaction. Okay, so here we have pyrrolidine and add pentan 3-on, and I want you to show that in that box here. That's step 1. And then step 2, you're going to add this acid chloride. Okay. All right, so that benzyl chloride, what is in that box? And then I want you to show the H3O plus in the water, step 3. Okay. So you have those 3 boxes, so that's problem number 1. All right, problem number 2. I have a lot of notes here, folks. All right, I found it. Here we go. Problem number 2. I want you to do retrosynthesis. You learned how to do this, so okay. So do the retrosynthesis for this compound. Problem number 3. Remember, you got to label alpha, beta, draw your line, okay? And then I want to see the reaction work forward as well. So draw your alpha, beta, your line. Show the 2 starting materials. And then show the mechanism, because you're going to have to know your mechanism forward. Also remember to get your tetrahedral intermediate in there for full credit. Okay, the other one here. So another retrosynthesis. Do that one. And then, so that's 3. Let's see if we can get 5 questions here. So number 4, I want to see this reaction. And 5, I want to see this reaction. And then, so there's 5 questions. Monday, what reactions do we have left? Let's look at next week. Okay, so Monday, I need to teach you about the haloform reaction. So Let me write that down. Yeah, so we're going to talk about the haloform reaction, and then I need to also, on Tuesday, I'm going to teach you about the Robinson annulation. Okay, and we're going to do some retrosynthesis on that. And you'll have problems from both of those that you can include onto this POGL. And that will be all the reactions of this chapter. Wednesday, I won't post, there'll be no online video. You'll have 10 multiple choice questions on sapling, on sapling, plus 5 open response questions posted here on your module. And then on Thursday of next week, I will go over your problems. Remember, you'll want to do your reworks, okay? So you can use that to do your reworks, and your reworks then go for your participation points in this class. So don't forget about that. And that'll sum up next week, okay? And then we'll start the following. I'll talk to you about that next week.